We now move to problem number 8, which states that find the length of the median from vertex C of a triangle ABC if AB vector is given to be 2k cap, BC vector is minus I cap minus 2j cap minus 2k cap, and CA vector is I cap plus 2j cap, where these denote the sides of the triangle ABC. So let's see how we'll tackle these kind of problems.
So let's move on to the solution. Here, three sides of the triangle are given. You must know that these do not represent the position vector of the vertices. Many a times there's a confusion. Like, you can represent a triangle in two terms. Let's say you give position vectors of three vertices,
Okay.
or other can be you represent the sides by vectors. These are two kinds of representations which we can follow. So let's say here it's A, it's B, it's C. This is first kind of representation, where position vectors of ends are given, vertices are given, and other kind of representation is opposite to the vertex C, you take vector C. Opposite to vertex A, you take vector A.
Okay.
And opposite to vertex B, you take vector B. So three sides are given. You take vector AB, so it would point towards B. Vector BC would point towards C, and vector CA would point towards A.
Okay. So these kind of representations we decide on the basis of the data given in the question.
Yes, if position vectors are given, then first would hold true. If the sides are given as vectors, then second would hold true.
Okay.
And in second, there is a must condition that A plus B plus C must come out to be 0, because the vector sum of the three vectors shown is 0. For any cyclic form of vectors, sum of vectors, it always the sum comes out to be 0.
Okay.
So we now move on to the solution. The given problem is of type 2. So we now move on to the solution. It's AB. AB is given, which is vector C, which is 2k. That is, this is 2k.
Right.
Okay, we first mention all the directions and then look forward to the solution. BC is given by minus I minus 2j minus 2k, and CA is given by I plus 2j. Okay, we know all the three vectors. Now first we must verify that the three vectors are the sides of a triangle or not. For that, we know the condition is A plus B plus C is 0. So let's verify that. So we are summing up all, which gives I plus 2j plus 2k plus minus I minus 2j minus 2k,
Right.
which clearly sums out to be 0. So they represent sides of triangle ABC.
Okay. So this is a useful criterion to check if it forms a triangle or not.
Yes, this is a very useful result which holds true for every polygon.
Okay.
Let's say it was a polygon of of four sides, A, B, C, D. Then A plus B plus C plus D must come out to be 0 if A, B, C, D represent the sides of triangle, sides of quadrilateral ABCD.
ABCD. Okay.
So it must be the case always. Now we move on. What we need to find out is length of median from vertex C to AB. Okay, so we need to find the length C. Let's say midpoint of AB is M.
Okay.
So we need to find length of M. Clearly, this is given as C, this is A, and this is B. So clearly we can find out that CM, which is vector pointing from C to M, which is this. CM is sum of two vectors, which is CA plus AM.
Okay.
This is by triangle law of addition of vectors.
Correct.
So now, as M is the midpoint of side AB, so AM would be half of AB,
Yeah.
because directions are same and magnitude of AM is half that of magnitude of AB. So AB is given as 2K, so AM would come out as K, and CA would come as I plus 2J, which is already given.
Yeah.
So CM vector can directly be written out as I plus 2J plus AM, and AM is given as K, which is I plus 2J plus K. This is vector CM. Now we need to find out length of CM. We know for any vector A, length of the vector is mod A.
Okay, the magnitude of that vector.
The magnitude exactly represents the length. Length is mod A. So here length would be mod CM, which is root of 1 square plus 2 square plus 1 square, which is root 6 units.
Okay. So as you have seen in this problem, one important concept which we have learned is how to represent the sides of a triangle. If the position vector is given, then we'll be following a different approach, and if the vectors are given as the sides of the triangle, then we need to ensure that the cyclic sum of all the three vectors is equal to 0. We followed the similar approach and we found out the position vector of the median, which is drawn from vertex C, and once the vector was calculated, the length of the median was directly given by the magnitude of that particular vector.
Exactly. Here important points to remember are this: for this kinds of problems, other is this: for this kind of problems we have AB would be given by B minus A, because AB is position vector of B minus position vector of A, and BC would be given as C minus B, and CA would be given as A minus C. So again similar laws can be applied over here as well.
Yeah, if you add all these three, the result would be 0.
Yes, clearly you can check out B minus A plus C minus B plus A minus C comes out to be 0.
Fine. Let's move to the next problem.
Yes.
Now we move to question number 10. Question number 10 states that if diagonals of a parallelogram are given by 2i minus j plus k and I minus j plus 5k, find the area of parallelogram. So this is the very typical question which is even asked in previous year entrance examinations. So let's see how we can find the area of a parallelogram when only the position vector of the diagonals is given.
So we need to find area of parallelogram whose diagonals are given. Okay, let's say this is the parallelogram. Okay.
Okay.
So the vertices are A, B, C and D.
Yeah.
Now here let's say AC vector, that is AC vector, is given by 2i minus j plus k,
Right.
and BD vector is given by I minus j plus 5k.
Okay.
These two vectors are given. Now we need to find area of the parallelogram. So by first method we need to know a direct formula for this. Area of a parallelogram is let's say A and B are consecutive sides of the parallelogram, then area of the parallelogram is given by mod of A cross B.
Okay.
Okay, and next, if D1 and D2 are two diagonals of a parallelogram, then area of parallelogram is given by half of D1 cross D2.
Okay, so this is a formula.
This is a general formula.
Need to remember.
Yes. Students need to remember this formula because this would make their problems quite easy.
Okay.
So even if they don't remember the formula, we'll like figure out second method for that.
Okay. So this
So-
is the first and the simplest method for
Yes.
solving, if you
The-
remember the formula.
Yes. So area equals half of d1 cross d2, which is 2i minus j plus k cross I minus j plus 5k, which is the mod of this. Okay,
Okay.
you need to take a mod because area is always positive, and also it is a scalar quantity, so hence.
Yeah.
Now cross product, we know that it can be found out like I j k 2 minus 1 1 and 1 minus 1 5, which is half of this is this minus this. Okay, so minus 5 plus 1 into I, which is minus 4i minus j into we need to like cross it out like this and take 5 into 2 10 minus 1 into 1 on 1, which is minus 9j. Okay,
Right.
now for k we need to hide out this as well as this and just take this, so it would be this multiplied by the minus this, which is minus 2 minus minus 1, which is minus 1 k. Okay. So area is given by half of minus 4i minus 9j minus k. So actually mod of this,
The magnitude.
which is 1 by 2 root of 16 plus 81 plus 1. So this is 82 plus this is 98. Okay, 98 is 49 into 2 and 49 is 7 square. So it would be 1 by 2 into root 98, which is 1 by 2 into 7 root 2, which is 7 by root 2 unit square. This is the area of the parallelogram.
So fine. This is the first method.
This
to
is the
solve.
first method, which is direct method. Another method, like we need to derive the formula and then solve. That is the second method.
Okay.
So we'll see how to derive this formula. This is a parallelogram. Vertices are given. Oh sorry, not vertices, the diagonals are given. Okay. Here it was given AC and BD. Now let's say A has position vector A, B has position vector B, C has C and D has D. So area of parallelogram is directly given as AB cross BC.
Okay.
This is like direct formula. This everyone remembers, like it's a very standard formula, so like there's no need to tell that you have to remember. It's understood that you must be remembering this.
Yeah.
So this is again mod of B minus A cross C minus B, which is mod of B cross C, B cross C, B cross
Right.
B, A cross C and A cross B. So B cross B term is coming out, which turns out to be 0 because both B are parallel to each other, hence theta would become 0. So B cross B equal to mod B sin theta, and as theta is 0, this would turn out to be 0.
Okay.
So area is B cross C minus A cross C minus plus A cross B.
Right.
Now as P cross Q equal to Q cross P, of minus of that, this is a standard identity. You must also know this because clearly this has a valid explanation. Let's say this is a vector P, this is a vector Q. So vector P cross Q would be found out by using right hand rule from P to Q, and then the right hand thumb rule we use.
Right.
Okay, so vector P cross Q would be pointing outward like this, like towards us.
Okay.
Okay, this would be vector P cross Q as we are turning from P to Q. Now Q cross P would be we are turning from Q to P. So by using right hand rule, the direction would go inwards, like into the plane, which is Q cross P. Now P cross Q and Q cross P both have magnitude mod P mod Q sin theta, where theta is the angle between P and Q. So magnitude is same and direction is different, hence this comes out.
Okay, so this is an important identity which the students must remember.
Yes, this is also an identity which is expected for the students to remember. So this comes out to be area of triangle. This again is a formula which is very important to remember, like which can be applied in many questions. Now we'll calculate d1 cross d2 mod of this. Okay, which is mod of C minus A cross D minus B.
Yeah.
Okay, which is mod of C cross D C cross D minus C cross B minus A cross D plus A cross B. Okay, this is mod of D1 cross D2. Now, by using the concept that AB parallel to CD, we can easily prove that mod of D1 cross D2 comes out to be twice of mod of AB cross BC. This can be easily proved by using this concept.
Okay.
That is, we would be using B minus A equals lambda times D minus C and AD parallel to BC.
Okay.
Using these two concepts, it can be easily proved that this is the required thing.
Okay.
So, as this is delta, which is area of triangle, area of the parallelogram, which would imply area is half of mod of D1 cross D2. So which the formula has been derived.
So fine. So we have shown you the derivation of this important formula. It will be great if you could remember this formula, as it will ease out the calculations involved
and save a lot of time.
Okay, so it's a direct formula based question. The displacement vector of the two diagonals is given. If you put the values in if you calculate the cross product and take its magnitude and divide it by half, you will get the area of the parallelogram. Okay, in question number 11 we have the perpendicular bisectors of sides AB and AC of triangle ABC are x minus y minus 4 equal to 0 and 2x minus y minus 5 equal to 0 respectively. The coordinates of vertex A are given to be minus 2, 3. Then in part A we are asked to find the circumcenter of triangle ABC, and in part B we need to find the coordinates of vertices B and C. So let's start with the solutions.
So let's get started. Here we have equation of the two perpendicular bisectors of a triangle. Two sides of perpendicular bisectors of two sides are given, and a vertex common to both the sides is given. Now first of all, diagrammatically represent everything so that the problem becomes easy. Vertex A is given as minus 2, 3, and equation of perpendicular bisectors of sides AB and AC are given. Okay.
Okay.
So this is L1, this is L2. L1 is given as x minus y minus 4 equals 0, and L2 is given as 2x minus y minus 5 equals 0.
Okay.
Okay. Now we know that perpendicular bisectors intersect, all the three perpendicular bisectors of a triangle intersect in circumcenter, like they are concurrent,
Right.
and the point of concurrence is the circumcenter of triangle ABC. So the point of intersection of the two given lines must be the circumcenter of triangle ABC.
Okay.
So in first part we just need to find the point of intersection of the two lines, which is the circumcenter of triangle ABC. So part A is quite simple. L1 and L2, we need to solve the simultaneous equations. Let's get started. Equation 2 minus equation 1 gives x minus 5 minus minus 4 equals 0, implies x equals 1. Putting x equals 1 in L1, we get y equal to minus 3.
Okay.
So the circumcenter of this triangle ABC is 1 comma minus 3. You can also check, does it satisfy the equation L2?
Okay.
So yes, it clearly satisfies, because 2 into 1 minus minus 3 minus 5, which is definitely 0.
Right.
So it satisfies both the equation, hence 1 comma minus 3 is the circumcenter. Now part B is a little tricky. You need to have a deeper thought in part B. We can think that how can we find out the coordinates of B and C.
Yeah.
Like giving a deeper thought would enable us to find out that if L1 is considered as mirror, then point A has its image point B,
Okay.
because L1 is the perpendicular bisector of line joining AB. So this point is equidistant from A and B,
Okay.
and also perpendicular to the line joining both of them. So it satisfies all the properties of mirror. What are the properties of mirror? A plane mirror. We have any object O placed above it will have mirror image exactly below at the same length.
Okay.
If this is L, then this has to be L, and this line, the line joining object and image, must always be perpendicular to the mirror.
Okay.
So all the conditions are being satisfied over here. So L1 is mirror for A and B, and L2 is mirror for A and C.
Correct.
So for part B, we need to apply the mirror formula, which is the best possible method to find out the vertices. Other methods can be there, but they are quite tedious, like you would have to solve a lot. So now let's recapitulate our mirror formula. If let's say this is a line and this is a point, x1, y1, z1. Let's say the mirror image has vertices h, k, l.
Okay.
It's all in 2D, so we not worry about the z coordinate. Let it be ignored. Okay. So equation of line is ax plus by plus cz plus the z has to be ignored. There's no need, because everything we are doing is in 2D plane, so no requirement of a third direction.
Okay.
So ax plus by plus c equal to 0 is the equation of line. So we need to know this formula, like the mirror formula, which you must be familiar with, that h minus x1 by a equal to k minus y1 by b equal to minus 2 times of ax1 plus by1 plus c by a square plus b square. Remember that this is not square root of a square plus b square, which a lot of students makes mistakes in this problem because they find out that root a square plus b square would represent a distance, whereas actually in the formula it is a square plus b square.
Okay, so students should carefully note this point in this particular formula.
Yes, this point has to be noted because many students make a mistake here and like get their answer wrong. So this formula must be remembered, because deriving this is a very tedious task which is almost impossible to do in the short duration of time. So we'll find out here in the given problem. For line L1, A is 1, B is -1, C is -4. So A is 1, B is -1 and C is -4. For L2 we have A is 2, B is -1 and C is -5.
Right.
X1, Y1, Z1 is common for both, which is point A.
Given as -2, 3.
Yes. So for L1 we'll get the coordinates of point B, which would be h minus -2 by 1 equal to k minus 3 by -1, which is -2 of ax1, which is -2, plus by1 -3 plus c -4 upon a square plus b square, which is 2. So this 2 gets cancelled over here. So h plus 2 equal to k minus 3 by -1, which is 2 plus 3 is 5, 5 plus 4 is 9, plus 9, which gives h comma k is 7 comma -6.
Right.
This is B.
Okay.
Now similarly we would find out C, which is h minus -2 by 2, which is k minus 3 by -1, which is -2 of -4 -3 -5 upon 5, which gives h plus 2 by 2 equals k minus 3 by -1, which is this 4 plus 3 is 7, 7 plus 5 is 12, which is 24 by 5.
Okay.
So C point is 48 by 5 minus 10 minus 10 by 5, which is 38 by 5, comma, this is minus 24 by 5, which, and in numerator it would be plus 15 by 5.
Yeah.
So it would give minus 9 by 5.
Okay, so as we saw in this question, the first part was a pretty simpler one. We only need to know the concept of a circumcenter, which is the point of intersection of the two all the three perpendicular bisectors of the sides of a triangle. So the equations of 2 were given. We had to simultaneously solve the two equations so as to find the point of intersection. In the second part, the important concept which we studied was of a mirror, of a line which acts as a mirror for a line joining any 2 points. We need to remember the mirror formula. If you remember the mirror formula, the question is pretty straightforward and you can substitute the values and get the final answer.
Just the thing was, you need to identify that if perpendicular bisector is there, then the two ends are like mirror images of each other with respect to the perpendicular bisector. This was the concept involved in this question.